All right, so relations and functions today, section 1.6. Again, we have one section left here. Finishing out chapter 1. We'll look into review next week, take our test next week. Relations and functions is a big review from Algebra 1, hopefully. Okay, so today will be a kind of review of what this really is. As we continue to progress through Algebra 2, we will deal with functions a lot. Okay, so what we're talking about today, you will have to have a good understanding of as we continue to progress through Algebra 2. For those of you who had double up and take geometry, I asked somebody in the hallway because you had one of these as a review problem in your geometry book. You already know what we're doing here today. You're a leg up. Okay, so that's great. But relations and functions. A relation is just a set of ordered pairs. Okay, there can be a small set, a big set, one set of numbers, two set of numbers. It's a set of the ordered pairs. And a lot of times when I denote sets, I use my squiggle bracket there to denote the numbers in the set. And as you look there at the examples, the set 0, 5, 0, 4, 2, 3, 4, 0, those are sets of those ordered pairs. Okay, those are the sets of the ordered pairs. Domain. Domain is one of those big key vocabulary terms that we're going to have to know. Okay, when we continue to progress through Algebra 2, domain is going to have to constantly stay with us. All right, domain is the set of all possible input values of a relation or function. Really, domain stands for the what values? Does anybody know? X. Domain is all my x values there. And if you look through my example there, the domain of the function f of x equals the square root of x. Well, x is anything where it's greater than or equal to 0. Okay, that'd be an example that we'll get to as we continue to progress through Algebra 2. We don't have anything as tough as that today for domain. But as we progress, we will start doing stuff like that with domain. But again, domain is all the input values or x values in a function or in a relation. Now, next one, range. Okay, range. Yeah, we don't ever think of range. We think of usually mean, median, mode, and range. That's a different term for range. This one is range of a relation or function. It's the set of output values of a function or relation. Well, if domain is x, my range is my what values, would you say, Autumn? Domain is x, range would probably be y. Nice job. Okay, so the domain is my x values. The range are my y values. Okay, so the domain is my x values. The range is my y values here. Okay, domain's what I input, x, range, y values, output, what I'm getting out. So for example, there, the range of y equals x squared. Y is going to be anything where it's greater than or equal to 0. Well, that makes sense because any number you plug in for x, it's always going to come back positive because you square it. So there's a good range example. And again, that'd be something that we'll progress to later on. Function. Function is a relation in which every input is paired with exactly one output. Okay, the key phrase there is it has exactly one output. All right, you can't have more than one output. Essentially, I think I asked Izzy in the hallway, you're one of them. What's that really say? What cannot repeat? Yeah, really, in order to be a function, x cannot repeat. All right, in order for it to really be a function, the x value cannot repeat. Essentially, my x value cannot go to multiple y values. Yes, sir?
What's the difference between that relation?
A relation, it does not matter if your x is repeat. So we can graph a lot of things and it'll be a relation. It's just not a function. So relation, what x values, any ordered pair can be a set of relation. Any set can be there. Good question. Now again, an example of a function. One of the best examples I've ever heard or ever known is when you think of like a vending machine. Okay, everybody's got a vending machine that has, all the rows of candy bars and all the rows of chips and all the rows of other things that are in there usually, right? A function is what you enter. So when you go to that vending machine, let's say you press in the code A1. You're going to get whatever is in A1. So if A1 is that Snickers, you're going to get that Snickers bar out. Okay, let's say I press the code B2. I get whatever's in B2 coming out. I don't press A1 and have multiple things that I could get. A1 goes directly to this one item. B2 goes directly to this one item. My input goes to specifically one output. Okay, that's an example of a function. A counter example of something that's not a function. Now, most of us here are hopefully familiar with Omaha. Omaha has multiple zip codes. Okay, if you didn't know that, it has multiple zip codes. So the city of Omaha has like 3 different zip codes. One city, 3 different outputs, not a function. Okay? So again, function, 1 input, 1 output. Not a function, 1 input, multiple outputs. Not a function. Okay? So again, a relation pairs input values, exput values. Same idea here. Just kind of going through another example. Domain, big thing for domain is the x coordinates, range of the y coordinates. Keep those 2 straight. Okay, and again, that's not just today, that's as we continue to progress throughout all these chapters. Keep those 2 straight. Down there, it says list the domain and range for the elements from least to greatest. That is kind of a detail when you're listing these. We always try to list our domain and ranges as a set from the least number to the greatest number. Again, like we talked about last week, you don't put decimals in the denominator. We don't have radicals in the denominator. There's all these little things that you keep doing with math. One of them is when you list the domain and range, list them from least to greatest. All right? And then you can also do domain and range with graphs. So down there at the bottom, it shows the domain and range of the graphs over here. As you look at there at the range, you don't ever repeat values. Once the number is in the set, you don't keep putting it in the set. It's there for good. You do not have to repeat values. So for example there, the range has 2 is the same. I only put the number 2 once there. Okay, then the number 0 is repeated. Well, I only put the 0 once. Once it's in the set, it's good. Okay, you don't need to put multiple numbers in the set. All right, so let's look at number 1 here. We want to express the relation for the track meet scoring system. Now, some of you that have not persuaded enough do track instead of baseball. It's all right.
For now.
But really what that means here is in a track meet, if you think about it, okay, if you get first, you get so many points for your team. If you get second, you get so many points. Third, you get so many points. Okay? Well, you can express this in a lot of different ways. You can express it as ordered pairs like they do. Or we can express it as a table. Okay? So if I express it as a table, I'll just do a T-chart table here. X, Y. Well, X value of 1 goes with what Y value? 5. Okay? 1 goes with 5. My X value of 2 goes with what Y value? 3. My X value of 3 goes with what Y value? 2. And my X value of 4 goes with 1. That's the way I can express these things as tables. Okay, again, these can be expressed in multiple ways. That's just one of them. Another way is I could use a graph. Well, to use a graph, I need the coordinate plane here. So I take my coordinate plane. And I plot my points. So I plot the point 1, 5. It's up there. 2, 3. 3, 2. And 4, 1. So I can express those points on a coordinate plane. I can also read from the coordinate plane my domain and ranges. All right. Or the third one, now you would have done this in Algebra 1. I don't think there's anything on your assignment dealing with the mapping diagrams, but just so you are aware, mapping diagram here sort of has the ovals, okay, and it expresses like all my x values here. So I have my x values of 1, 2, 3, and 4. My y values are 1, 2, 3, and 5. A mapping diagram expresses where they go. So for example, 1 is paired with 5. Well, it expresses that by showing a line, 1 goes to 5. Okay, same, 2 goes to 3, so I put a line from 2 to 3. 3 goes to 2, I put a line going from 3 to 2. 4 goes to 1, I put a line from 4 to 1. That's a mapping diagram. Okay, it just shows from how one point gets to the other. Mapping diagrams, again, one of the only places I've really seen it is with like mail delivery or postal delivery. They use mapping diagrams to help kind of draw out the routes. But again, that's kind of very uncommon to see mapping diagrams. You see more of the first two than you do the third. All right, try this one on your own here. Make a table and a graph. Okay, if you have time, you can make the mapping diagram as well. Sorry, I backed up. All right, here we go. So I'm going to express this as a table. So if I express it as a table, what are my x values here, Cassie? Just the x values. 1, 2, and 3. And what are my y values in that table then? Cassie. Chunks? 3, 3, 4, and 5. Nice job. So you can see in the table how 1 is with 3, 2 is with 4, and 3 is with 5. If I do a coordinate plane here, oh, there's my dots. You plot the points, so 1, 3, 2, 4, and 3, 5. Okay? If you did a mapping diagram, basically your lines are going to go straight across. So 1, 2, 3, 3, 4, and 5. And here your mapping diagram will literally just go straight across. Okay? Next, we're going to talk about domain and range.
So we're not doing number 3?
Nope. You guys got to feel for number 3. So domain and range. Let's see. Tyler, domain is my what values again?
Domain is your y. No, wait, no, they're your x.
Domain are my x values. Again, make sure you have that clear. Domain x, range y. So domain, I want to list out my x values in this set. And again, we talked about it. We always go from least to greatest here. What are the x values in that set? Jack, what are the x values in that set?
1, 3, 5, 4, 2.
Now, I do agree with that.
Start 1, 2, 3, 4, 5.
Thank you. Make sure we always put them from least to greatest. And because I'm taking a set, I put my set symbol up there. Next, I'm going to do my range values. Okay. What values are in the range? Nolan?
2, 5, 6, 5, 8.
So 2, 5, 6, 5, 8. So what's the range then?
What?
I agree, those values are in there.
Uh-huh.
So how would you say the range? What numbers are in the range?
2, 5, 6, 8.
There you go. We do not need to put the 5 twice. Okay? That's the key there. When you're listing the set out of domain and range, do not repeat the values. Once the number's in there, it's in the set. Yes, sir.
Can you like classify those as relation or function?
We will do that. You could. What do you think it is?
Relation.
This one, number 4 would actually be a function because none of the x values repeat. But we'll look at those here in a little bit as well. Yep. All right, next here. I want to find the domain and range of these coordinates. Okay, I want to find domain and range of these coordinates. If I want to go from least to greatest. So looking at my coordinate plane, I want to list my domain, my x values from least to greatest. As I look at my graph, which way would be easiest? Which way should I start and go to finish?
Left to right.
Very good. I want to go left to right. So I'm going to start with this coordinate right there. What is the x value for that coordinate there, Lane? Thank you. And then I go to my next coordinate. What is the x value for that coordinate, Jersey? And my next coordinate, Destiny? My next coordinate. 0. Now come my next coordinates. Now again, note they're the same, so I don't need to repeat them. What would be the coordinate there, Jack? What? Thank you. My next coordinate is what, Nick?
2.
And my last coordinate, Autumn? So there are the set of domain. Now I look to find my range. Same idea if I want to go from least to greatest now. Where should I start at if I want to go from least to greatest? Bottom and work up. What is the y value there at the bottom, Colton? My next y value is Tiana. -1. Formatting error. Formatting error. Next one, Marisol. Next one, Sequoia. And the last one, Tyler. 2. And again, note, we don't repeat those values. All right? Try these two. Find the domain and range. What is the domain for number 6, Autumn? Give me the domain.
-5, 0, and 1.
Thank you.
Wrong one, sorry.
There we go. Give me the range for number 6, Cassie Tech. 1, 2, 3, 4. Nice job. Number 7. What is the domain for number 7? Austin, what's the domain?
Oh, God, I don't know.
What are the x values in number 7?
Oh, 2, 0, 3, negative 1, 2, right?
Yep. Now, anytime we list a domain, we put them from least to greatest. So, -1, 0, 2, and 3, right? And again, because 2 repeats in there, I do not need to repeat it in my set. Once it's in the set, it's good. 7. Nolan, what's the range for number 7?
278.
2, 7, 8. Doesn't matter how many times it's repeated, like the number 2 up there. I only got to put it in my set once. Number 8. We're going to talk if this is a function or not. Now, what's the key to being a function? What value cannot repeat, Jack? The x. So as I look at my x values here, the x are my right values. Or sorry, my left values. My y is my right values. So I look at -2. -2 goes to just -3. 0 goes to 0. 3 goes to -1. 4 goes to -1 and 3. What's wrong with that? Yeah, 4 has 2 different outputs. So number 8 is not a function. Okay, number 8 is not a function because 4 goes to both -1 and 3. Okay, again, one value can mess it up for everything. All right, number 9. -4 goes to 0. -2 goes to -1. 0 goes to 2. 1 goes to 2. 2 goes to 3. Is number 9 a function, Nick?
Yes.
Yeah, number 9 is a function. Looking at a problem like that, why might somebody say that would not be a function?
0 and 1.
Yeah, because this value right here. But what do we know? What value can't repeat? X's. Y's can repeat all it wants to. It's the x values that cannot repeat. All right, next here. I'm going to show you the vertical line test. Does anybody here remember the vertical line test from Algebra 1 a little bit, maybe? Okay. Vertical line test can be used for graphs. All right, so as I look at number 11 here, as I take my vertical line across this graph, okay, does it ever hit this vertical line twice?
No.
Yeah, it does.
A couple times.
As you look at it, well, it hits my vertical line. If I had a vertical line right there, it hits it twice. A vertical line there, it hits it twice. That is an example of not being a function. Okay, because my x value right there goes to 2 different y values. All right, it is not a function. Look at number 12 here. Okay, would this satisfy a function or not? Again, these arrows are going up and out left or down and out right. Would this be a function? Yeah, it would be a function because none of the x values would repeat. Try these 3.
Done. There's nothing.
All right, as I look through these, number 13. Is number 13 a function? Tiana, is that a function or not? Yes, this is a function. None of my x values repeat. What about number 14? Is 14 a function?
No.
14 is not a function. What values repeat?
3,
And
2.
2. Yeah, that one satisfies both. 3 repeats, 2 repeats. Okay, it's not a function. What about number 15? Function or not a function?
Yeah.
Number 15 is a function. The y values repeat, but it doesn't matter about the y. It's all about the x values.
What do we write? Do we just write yes or no? I already said like
Function or not a function?
Oh.
Can I shoot?